Hi everyone, my name is Olivia. I'm a master's student here at the University of Wisconsin-Madison, and my work and my poster will be on identifying LEO satellite interference for radio astronomy. So with the rapid rise of satellites in low Earth orbit, they can emit a lot of harmful radio frequency interference that is very disruptive to sensitive radio astronomy observations. So while this interference is detectable, it is not necessarily identifiable by radio telescopes. Our work here tries to identify the source of radio frequency interference by ultimately applying a new method of Doppler compensation. And yeah.
Perfect. I think that's it. Thank you.
Hello, everyone. My name is Nessie Joseph. I am a PhD candidate under Dr. Bernardin at Florida A&M University. And my project is part of a two-parter. So what I'm presenting today will be the first part of my project, which is a large language model looking at different types of RAG models and then eventually creating a multimodal model. All right, thank you.
Hi everyone, I'm Sarah from UW-Madison. For our project, we built a platform where researchers can submit and compare models that detect whether a device is indoors or not using ATSP signals. This helps with frequency spectrum sharing by mitigating interference between users. While designing such models, it is important to keep in mind frictionless reproducibility principles. These include shareable code, data, as well as competitive challenges for researchers. And this platform is a step towards adopting these principles. Our platform is available for use on Hugging Face and is currently being used by students at UW-Madison, and Gianna also helped with this project. I will also be presenting the next project, if that's okay. The student who helped me with this project couldn't be here, so I'll also, yeah. So for the next project, we built a visualization dashboard for satellites that are within the field of view for a certain ground station. The orbits of these field of view satellites are important for understanding things like connectivity, interference, etc. And these are growing areas of research because of the growing number of satellites in recent decades. We used three main plots. One is the Doppler profiles of the satellites. One is a polar plot, and the third one is a 3D dome plot. This dashboard is available for use on Hugging Face as well. Yes, thank you.
Hi, I'm AJ. I use they, them pronouns. I'm a PhD student at CU Boulder. In my poster, I'll be talking about preliminary measurements that I've taken to see if we can use variations in RSRP data to estimate rain rate. And we're doing this as kind of a case study in coexistence through dual use communication and sensing.
Hi everyone, I'm Muhammad. I'm a postdoc on Notre Dame. I'll be presenting SIGCAP as a platform for crowdsourcing and analyzing broadband wireless data. And as you might know, maybe like the first at the Caleb's talks this morning. So SIGCAP is a program that is in the Android, and it takes a lot of data such as like 4G, 5G, RSRP. So those can be like collected, and what we are what we're doing is we're trying to collect that inside of one data platform that you can quickly view. And yeah, just come visit also our demo today. Thank you.
Hi everyone, my name is Solby. I'm a junior at University of Notre Dame and I'm with Dr. Laneman's office or lab. My project is to design and build a satellite ground station on campus that can monitor and detect power signals in V-band. I'm particularly interested in the V-band. And my poster is probably going to be a Q&A session where I ask the questions because I need to figure out a lot of things. So I'd appreciate if you stop by. Thank you.
Hello, everyone. My name is Christopher Wall. I'm a PhD student at the University of Notre Dame, and my poster today is about spectrum sensor placement optimization for radio occupancy mapping. Namely, we have two approaches depending on what is known about the environment, with the end goal being to maximize your estimate accuracy.
Hi, everyone. My name is Zhi Yushen from the University of Notre Dame, and I'm advised by Professor Hawkwood, and we're proposing a phased array antenna design for V-band LEO satellite communication. And our design uses true time delay beamformer to support wideband communication, and also we propose a low loss front end structure to keep the receiver noise power low so that we require less ERP from the transmitter, thus enabling the spectrum sharing between the SATCOM and the terrestrial fixed services. Thank you.
Hi everyone, my name is Vasu. I'm from the University at Albany. Maria actually gave a nice overview of my poster, which is on multispectral characterization and our measurement campaign to study harmonics. So my poster, I'll be talking about our characterization method and our measurement campaign, which we did in lab and also at the Green Bank Observatory.
Hi everyone, my name is Blessing Okoro. So my poster is about a framework for joint time, frequency, and space transmitter characterization using tensor-based factor decomposition. So we collect data from multiple sensors and model this data as a three-way tensor, which captures the time, frequency, and the spatial dimension. Then we apply the tensor decomposition framework to this data, which isolates transmitter components from this data into different rank 1 components. And using these tensor components, we can be able to jointly detect and localize transmitters with just a single multispectral, multi-vantage point measurement. Thank you.
Hello, I'm Angie Cruz. I'm a researcher with University of Colorado Boulder. My research is on analyzing 5G RFI on the Advanced Technology Microwave Sounder, or ATMS. So we know that microwave radiometers are crucial to numerical weather prediction models, but they're also inherently susceptible to RFI due to their measurements of natural low power emissions. So for this work, I'm analyzing on-orbit ATMS data that's collected over metropolitan areas with deployed 5G millimeter wave networks. Then I'm comparing that to ground truth that's calculated using CRTM, which is a community radio transfer model with inputs of the sensor spectral characteristics, as well as atmosphere and ground profiles that are pulled in from ERA5, which is a real analysis data set from ECMWF. We then calculate the observation minus background bias and see if we can find indications of RFI. So for my poster, I'll be describing the processing framework that we've developed for this research, and I'll also provide an initial hypothesis of the change in brightness temperature that may be caused by 5G millimeter wave N261 second harmonics. Thanks.
Hello everyone, my name is Blake Hutchins. I'm a student at Blue Ridge Community College in Virginia. This summer I did an REU with the NRAO, where I looked at archival study of Starlink's effects on VLA scientific observations.
Hi, everyone. My name is Maria, and I'm not a student. But I figured if I'm given an opportunity to belong to the better half of us, I'll take it. My poster is not even on research. So. Anyhow, my poster, which is joined between me and Anya, is actually on the summer school. So it focuses on sort of the program, and more specifically on what we've done this year and what we're looking for if you're excited to join us and become a site. So if you're interested in that, come and see us.
Hi everyone, my name is Yan Kai. I'm a second-year PhD student from University of Notre Dame, and my work explores how mobile satellite direct-to-device uplink signals, which operates right above the GPS band, might interfere with GPS receiver receptions. And to investigate, we built a simulation framework, and then first we recorded the out-of-band emission data using a Iridium transmitter, and then we built the simulation framework to model the aggregate interference. And after that, we evaluated how these emissions might affect the GPS receiver metrics such as signal quality and position error using a software-defined GPS receivers. And the preliminary result is that within the simulation range, the interference has limited effect to GPS receivers. Thanks.
Hi, I'm Thomas, and I'll be presenting work I did on a project called FireHound. So RadioHound is Notre Dame's distributed wireless sensing platform that generates heat maps of spectrum usage. My work was in looking at a way to increase the sampling rate of this platform, and what I came up with was using something called a Beagle v Fire, which has an integrated FPGA fabric. This allows for higher speed ADCs to be used on the RadioHound to take in data at a higher sampling rate. It also allows for scalable resolution of this ADC, and it does all of this while not majorly increasing the total cost of the platform. So that's what I'll be talking about in my poster. Thank you.
Hi everyone, I'm Michaela. I spoke earlier in the student panel, and I'll be presenting my poster that I made for my REU at Notre Dame this July, and it covers using AI agents and ragging techniques to answer questions based on FCC data. And I did this to explore the use of AI agents in Bingyan and Songwei's bigger project of SpectrumRag.
Hi, I'm Song Wei Dong, and I'm a second-year PhD student, and my supervisor is Song Shen. And I'm going to share about our project, SpectrumRag, a retrieve augmented generation system for spectrum policy research. And in this field, researchers may want to do some policy making and deal with some huge amount of data, like unstructured data like FCC proceeding documents, and also structured data like license records. And so it takes time to connect these two. So we ask ourselves, can we make this process more smarter or faster? And that's where the SpectrumRag comes in. It's a multi-agent RG system with one supervisor agent and also 3 sub-agents. And by working together, they can answer some very complex questions. And in our demo, we collect both license data and also policy documents. And if you are interested in this topic about satellite spectrum abundance, please feel free to ask our question about it. And also we are able to try our demo in the server. Also, I will place a laptop beside it, and you can play it in person. Thanks.
Hi everyone, my name is Swarup Gopalan. I'm a postdoc at Northwestern. My poster is called Distributed Sensing and Beacon Mechanisms for Improving CBRS. The motivation for it is the following. We want to reduce the reliance of CBRS on models by using some real-time data obtained using sensors or some real-time signals transmitted using beacons, and use that for making interference estimation or move list calculations. If you want to see some results on this, please come to my talk.
Hello, I'm Zhong Yun, a PhD student at Northwestern University. My poster title is Security Investment Strategies in Shared Spectrum Markets. Well, as the title suggests, we build economic model about the SP's interactions in the shared spectrum markets under the threat of a potential attack, which is security threat. And we will analyze the equilibrium cases and also to see how the risk aversion of those SPs influence the outcome. Yeah, if you're interested in, feel free to stop by and ask questions. Thanks.
Yeah. Hello, my name is Anas Saleh, and here is Nevam Marakji. We worked with Dr. Parker last summer, in which we were able to design a pre-selector bank of bandpass filters.
So we made a printed circuit board. On one end, we could attach an antenna where all the frequencies go through, and it goes through a switch, depending on which bandpass filter we want the energy to go through. And on the other end, we get our desired frequency, and all the other undesired frequencies are cut out.
Hi everyone, I'm Mehmet Can, a PhD student at Northwestern University. So our work is basically about the non-cooperative coexistence of a radar and then OFDM communication system. So we basically formulate a hypothesis testing problem. Instead of working with the receipt signals, we instead reformulate it as some investigation on the errors of the beamformers, downlink beamformers optimization. We develop few heuristics to detect the presence of a potential radar based on the errors of the beamformers.
Hello, my name is Manos Suarez. I'm working with Carlos Crespo right here with Satish at FIU, and our poster title is called Machine Learning Enabled Creation of Radio Environment Maps Using Real-Time Coverage Mapping.
Hello, I'm Carlos. So what we want to do is create dynamic REMs. And we have a lot of data we've recorded around FIU's engineering center. But that data on its own is not enough because signal strength is going to look different from day to day, even in the same area. So we're going for a hybrid approach where we're marrying our SIGCAP data with simulated propagation models we made using Altair WinProp. And what we want to do is train an AI model using our SIGCAP data and our propagation models to make dynamic REMs.
Hello, everyone. My name is Yanzi Li. I'm a PhD student from Northwestern University. To optimize our spectrum resource management problem, we try to answer two questions. First is how to construct the interference model from limited or sparse measurement. And then, based on this interference model, how to allocate spectrum resource efficiently. So notice that we can model both problems as either graph completion problem or graph optimization problem. So as a result, we plan to utilize the newly emerged graph neural network to solve both problems. So the message processing nature of graph neural network allows it to explore the internal graph structural information in both problems that are usually omitted in traditional optimization approach. So that's how we plan to solve this problem. Thank you.
Good afternoon. My name is Joshua. I'm from the University of Notre Dame. The title of my poster is Indoor Sharing in the Mid-Band, a testbed evaluation of neutral host, cellular macro, and Wi-Fi. So my work tries to address the challenge of reliable indoor wireless coverage. Buildings weaken cellular signals and Wi-Fi suffers from congestion and long range. So using the CBRS band, we evaluated shared spectrum as a solution and examined the neutral host model, private network neutral host model. We have in tests inside a large retail store, we have proved that CBRS delivers stronger coverage and higher throughput with less infrastructure. Thank you.
Hi everyone,
My name is Hossein Nasiri, and I am a third-year PhD student at the University of Notre Dame. My work is on indoor-outdoor classification of environment by using GNSS satellite data. And the new spectrum sharing policies heavily rely on the indoor-outdoor information, but today there is no reliable way of doing so. And we have developed our own models and actually added them as a new feature to the CCAP application that you have already heard of. Thanks.
Hi everyone, I am Federico Bobbio. I am a postdoc at Northwestern, where I work with Randall Berry and Michael Honig. I'm on the job market this year. Good luck. Spectrum is getting crowded. Everyone wants access, MNOs, satellites, defense, and science. But when commercial satellites share spectrum with radio telescopes, interference may arise, as we well know. Each side knows privately the parameters that create the interference. In economics, for example, the textbook to fix this problem would be to have monetary transfer from satellite to radio telescope. Though this is not possible, and the reason is because that would distort the mission of radio telescopes. But what we can do is that we can raise money from satellites in order to access the spectrum and use those money to run inspection over radio telescopes in order to make sure that the interference is well kept under certain thresholds. And indeed, this is the kind of mechanism that we propose. A threshold, simple, elegant mechanism that can be described analytically from a mathematical perspective and that can be deployed by the NTA and the FCC. In short, we provide a tractable way to manage shared spectrum on any public resource when money can buy honesty. Thank you.
Hello, I will be presenting the poster about the phase array design. So talk to you and give more details about a conversion board, antenna design, data converters, thermal simulations of the encapsulation, and also get some feedback from you of what type of demonstration. Also give you some an overview of what we are planning for the anechoic chamber demonstration, and also getting some feedback of ideas of how we can use and experiments that we can do with the phase array platform. Thank you.
All right, you should know who I am. My postdoc, Sam, could not be here, but he kindly created a really wonderful poster about work for Flagship 2 that Daniel, Sam, and I have been doing. And we're going to be talking about interference in radio astronomy protected bands. In particular, the bottom of the Starlink band, just below their bottom transmission down at 10.56 gigahertz, as well as what we've been doing at 1420 megahertz at the hydrogen line band with a system capable of coincidence detection between the Westford Radio Telescope and our Haystack, our MIT 6-meter big dish, which is on campus. The short summary of it is that there is, at least up at X-band, significant interference in our absolute calibrated flux measurements. We're comparing to ITU thresholds. There will be papers forthcoming in the literature in the not too distant future. But now I'll admit I didn't actually print Sam's poster because I was a little busy with other stuff and getting here. So I will have it as a very small thing on my small laptop display. But I invite you to look at the online posters, which were kindly put together. Thank you very much.
That was all Steph.
Thank you very much, Steph. And so that would be the best place for you to get a detailed read of that poster.
Great.